the definite integral might not represent the area. We know that to find the area, we integrate the difference between the upper curve and the lower curve, the integral from a to b f of x minus 2 of x dx, assuming that f is the upper curve and g is the lower curve on the interval a comma b. Consider the area of the region bounded by y equals cosine of x and y equals sine of x from x equal to 0 to x equals pi over 2. If we were to blindly set up the integral from 0 to pi over 2 and taking one function minus another, in this case, we take cosine of x minus sine of x dx integrated from 0 to pi over 2. The antiderivative of cosine is sine, and the antiderivative of negative sine is positive cosine. Evaluate from 0 to pi over 2. Using the fundamental theorem of calculus, we plug in pi over 2 into the antiderivative, and we plug in 0 into the antiderivative. Sine of pi over 2 is 1. Cosine of pi over 2 is 0. Sine of 0 is 0, and cosine of 0 is 1. And so, this definite integral is 1 minus 1, or 0. Notice that the area between the two curves are the shaded regions. This cannot possibly be 0. There is something there. Even if we set up the definite integral in a different way, taking sine of x minus cosine of x as the integrand, the antiderivative of sine of x is minus cosine of x, and the antiderivative of cosine of x is sine of x. Evaluated from 0 to pi over 2, using the fundamental theorem of calculus, we have negative cosine of pi over 2, minus sine of pi over 2, minus cosine of 0, minus sine of 0. Minus cosine of pi over 2 is 0. Sine of pi over 2 is 1. Cosine of 0 is 1. And sine of 0 is 0. We still end up with minus 1 plus 1, which is 0. What this shows is that the definite integral does not represent the area of the bounded regions between the two curves. In order to use the definite integral to represent the area, we need to make sure that f is greater than or equal to g on the interval a comma b. If f is not the upper curve and g is not the lower curve on the interval a comma b, then we need to make sure to rewrite the definite integral so that on each of the integral, the integrand is an upper curve minus the lower curve.